Hi there, Mr. Holcomb here again with another episode of Math Behind the Modules. Okay, lesson 22 is an exercise in changing scales. The classwork I decided to skip over because the students all had different scale factors from the previous lesson 20, and all our values would be different. So let's skip this for the video, and we'll start with example 1, building a bench. Okay, so it says, to surprise her mother, Taylor helped her father build a bench for the front porch. Taylor's father had the instructions with drawings, but Taylor wanted to have her own copy. She enlarged her copy to make it easier to read. Using the following diagram, fill in the missing information to complete the first row of the table. Write the scale factor of the bench to the bench to the original diagram, and the bench to Taylor's diagram. Complete the remaining rows similarly. The pictures below show the diagram of the bench shown on the original instructions and the diagram of the bench shown on Taylor's enlarged copy of the instruction. So the one on the left here, original drawing bench on the paper was 2 inches. Taylor enlarged it to make it 6 inches, and the scale factor to the bench was 1/12. Okay. So if I start with the bench, let's work on this first. Okay, like always, we're going to use that famous equation, y equals kx. Alright? But what is confusing is what is y, what is k, and what is x? Well, y, in this case, is our drawing. Hopefully this will be less confusing, because this is what the students had trouble with, setting it up. X is the scale factor. Hopefully they all knew that at least. And not x. K is the scale factor. I apologize. K is the scale factor, and x is the actual bench. Okay, the actual. After being built, that'll be our x. All right. So, if we were given the scale factor to be 1/12, I would fill this in where y is our drawing, k is our scale factor, so I can put 1/12 here. And what were we given here? We were given the actual bench. So the bench is actual, that's x, so that's going to go here. All right? So y equals 1/12. That's Taylor's diagram. So that's going to go here. All right? But we're going from Taylor's diagram back to the original. And if I set it up this way, if I say 2 is to 6, right? 2 inches is to 6 inches. That would be putting the original drawing on top and Taylor's drawing on the bottom. Would be equal to something, let's call it x here, over 1/12. Okay? And if I cross multiply, I get 6x equals 1/6. Divide both sides by 6, and I get x equals 1/6 times 1/6 instead of divided by, and I get 1/36. Okay, that may be a little confusing to the students, so really all I'm doing is dividing it by 3. 2 inches is 1/3 of 6 inches. So if that whole algebraic solution was confusing, now let's just think of it as, oh, well, that's just 1/3. So 1/12 times 1/3 equals 1/36, because 2 is 1/3 of 6. Is that better? Hopefully that's less confusing, more direct. Okay. Now we're going to do the same thing with the original diagram. So in this example, we were given our original diagram of 1. So now let me just erase this. Okay, what were we given? We were given the original diagram, data. dad's diagram, 1. Well, we already know that it's a third of Taylor's diagram, where Taylor tripled it. We went from 2 to 6, so 1 times 3 is 3. Okay? So now if we use this equation, y equals kx, now all we need to find is the actual bench, and that's x. So I know y. I know my scale factor. Now I just need to find the size of the bench. So we need to set this up and find the original diagram. For the original diagram, what's the size of the bench going to be? All right. Scale factor to bench is 1/12. Okay. Y is 3 in this case. Y is the drawing, Taylor's diagram. We don't know what the bench is going to be. To solve this, we multiply both sides by 12. 12's cancel, and we get x equals 12 times 3, or 36. Okay. There's our answer there. Now we have one last calculation to do. And it's Taylor's diagram. Alright? So we know k is 1/12. Do this for that. We know k is 1/12. We were given Taylor's diagram as 1. And we need to find y. So, let's see. No, that's not right. I know the scale drawing is 1/12. Y is the drawing. My apologies. We need to find x. So what we have to do to get x by itself is multiply both sides by 12. And the 12's cancel. We get x equals 12 times 1, which is 12. Okay, so the bench is 12. The original diagram, if this is 1, remember the original diagram was taking Taylor's diagram of 6 and dividing it by 3. Well, 1 divided by 3 is 1/3. Okay, and there is the scale factors of going in each direction for everything. All right. Exercise 2. Ronald received a special toy train set for his birthday. In the picture of the train on the package, the boxcar has the following dimensions. Okay, so I'm going to use red for the package. So here are our measurements from the package. The toy boxcar that Ronald received had dimensions of 17 1/4. Please, you can see it. Length of 17.25 inches, width of 4.5 inches, and a height of 6.5 inches. Okay? That's the actual toy. Here's the actual toy. And the last piece of information we are given is the actual boxcar in real life is 50 feet long. Okay? So it says find the scale factor of the picture on the package to the toy set. So what are we comparing? Scale factor of picture on the package to, here's our key word, the toy set. Okay. All right, the first thing I want to do is convert these fractions and decimals to improper fractions so everything is nice and in the same unit of measurement, so forth, or same format. So if I do length, and I'm going to use color coding here, so red is the package, blue is the toy, and green is the action. So 4 and 5/16 is the same as 16 times 4, which is 64, plus 5, which is 69 over 6. So there's the improper fraction length. The width is going to be 8 times 1 plus 1, which is 8 plus 1, which is 9 over 8. 1 and 1/8 is 9/8. And the length of the picture is 8 times 1, which is 8, plus 5 is 13/8. Okay? I'm going to do the same thing with the dimensions of the actual toy. I'll do that in blue. 17.25 is 17 and a quarter, which is 17 times 4, which is 69, or 68, plus 1 is 69 over 4. The width of the toy is 4 and 1/2, which is 9 halves. 4 times 2 plus 1. And the length is 6.5 is 6 and 1/2. 6 times 2 is 12, plus 1 is 13 over 2. Now we have all these improper fractions. All right? And while we're at it, the actual boxcar is 50 feet. Well, if we're dealing with inches on the box and inches in the toy, then let's deal with inches in the boxcar. So 50 times 12, because there's 12 inches in a foot, is 600 inches. All right, so now everything is in inches, and everything is an improper fraction. And if we make the actual an improper fraction, it's 600 over 1. Okay. So A says find the scale factor of the picture on the package to the toy set. So picture on the package to the actual toy set. We can use any one of the three. I could use length to length, width to width, height to height. I will use the length. So I would take 4 and 5/16, which is 69 over 6. So we're going to take 69 divided by 6. And the word 2 means to divide. There's my word 2. So we're comparing length from the box to the toy, which is 17 and a quarter, which is 69 quarters. Okay, so we're taking the length of the picture on the box dividing by the length of the toy. And that is going to be the same as 69 over 6. We cannot divide a fraction by a fraction in math. We have a rule that we take the denominator and flip it and turn the division into multiplication. When we do that, the 69's cancel. The 69 divided by 69 is 1, and 4 over 6 reduces to 2/3. Okay, while doing this, I noticed I made a mistake, and I'm just going to fix it right here. There's a 16 right here. Right there's a 16, 5/16. I said 69/6. It's 69/6. 69/6. 69/16. So when I do this, I get 4 over 69. The 69 still cancels, but I get 4 over 16, which is a quarter. Okay, apologize for that. Drop to 1. Okay, B says find the scale factor of the picture on the package to the actual boxcar. So scale factor of the picture on the package. Again, we're going to use the same thing. Let's just stay with length. 4 and 5/16 over the actual boxcar. So this is going to be 69 over 16 2, that's what the word 2 means, divide 600 over 1, which equals 69 over 16 times 1 over 600. Which equals 69 over 6,400 6,400. And those will reduce. And it reduces to it's not 64. 0, 0. 6 times 6 is 36. 3, 6, 9,600. And those are both divisible by 3. So if I divide 69 by 3, I get 23. And if I divide 9,600 by 3, it's 3,200. So the scale factor of the picture on the package to the boxcar is this. And that is our K, or our scale factor. All right. So now when we move up here to C, it says use these two scale factors to find the scale factor between the toy set and the actual box. All right? Use these two scale factors. So the scale factor of the picture to the toy set was a quarter. So I'm going to write this in words to show this to you before I do it with numbers. Okay, so this said picture on the package to toy set. So this is the picture to the toy. Scale factor between the toy set and the actual boxcar. Now this one here is the package, picture on the package to the boxcar. Okay. We want to get the toy set to boxcar. We want toy to boxcar. We've already done package to toy set and package to actual boxcar. So looking back up here, package to toy set, package to toy, and then here we did package to actual. Package to actual. Okay. Now if I put this into words like this, I want something to cancel. And we're looking for toy set and actual box. So here's toy, here's actual. We want these packages to cancel. They're not going to cancel if they're both in the numerator, so I need to flip one of these. And it doesn't matter which one I flip. So I'm going to flip this one. So I'm going to redo this as package to toy as over actual to package. So I want pack is to toy and actual to pack. So the packages cancel and I get actual over toy. So if I do that, it's backwards. Here's toy set, here's actual. Alright? So it depends on which one we flip as well. So that didn't work. So this is what the students need to be able to understand. What are we going to adjust to get the right answer? And that's where the biggest confusion comes in. This is a really challenging process. So I'm going to flip the toy over the pack and leave pack over actual. And then the packs cancel and I get toy to actual. Toy over actual. And there it is. Toy actual. All right. So I want toy over pack. Toy set to pack, which would be 4 over 1. I want to flip that times pack 23. It's a 3,200. Okay? So when I do that, I get $23. This will cancel with this, and I get 23 over 800. And that is our K from the toy set to the actual boxcar. Okay. Then D says, what are the width and the height of the actual boxcar? So now we're going to use our scale factor 23/800, which is the toy set to the actual boxcar, and we want to find the width and the height. So I'll do the width first, and if I come back up here, we want to use the dimensions of the actual toy, not the picture. So the toy boxcar width is 4.5 inches. So if I come down here, 4.5 is 9 halves. And I'm going to divide that by my scale factor from the last step, 23/800. That's going to equal 9 halves times 800/23. And then 2 will cancel that 8, make it 400. So I get 3,600 divided by 23, which equals 156 and 12/23 inches. Okay, so I just used a calculator. 3,600 divided by 23, and it's 156 with the remainder of 12. Long division as well. Now let's find the height. So I go back up to the top. My height of my toy is 6.5 inches. 6 1/2 is 13 halves. And I'm going to divide that by that 23/800, which equals 13 halves times 800/23. And the 2 and the 8 will make 4. And 13 times 4, 12, 5. Divided by 23. Now if I do long division, 5,200 divided by 23, it will come out 226 with the remainder of 2. So 226, 2 2/23 of an inch. That are the width and the height of the actual boxcar. Okay? A little confusing when we start taking our y equals kx formula and applying it to real world situations. But we have to be careful. Hopefully I didn't confuse you with this portion right here. But we have to figure out how we're going to set this problem up in order for things to cancel out so we get the right answer. So we aren't, because if we did it wrong, if we didn't flip that pack over toy, we'd get 800/23, and that would be the wrong direction in our scaling. The drawing is not bigger, or the toy is not bigger than the actual train. Okay. Hopefully you can now go do your problems.